any of it, or for those of you that are absent. So if you got a friend that's not here or something like that, and you want to let them know, definitely let them know that the video is going to be up so that they can take a look at it. Okay. So let's just jump right in on question one. So you have an abstract interface and class, right? So the interface is circus performer, and the big thing that you want to understand, especially if you're going into the AP exam on interfaces, is that everything in the interface is going to be public. You don't even really have to write public. You don't have to declare it as any of these things, but by default, it's going to be public and abstract, meaning any class that you write that implements that interface is going to have to override any of the methods that are contained in the interface. Otherwise, you're going to get an error. Okay. The other thing is if you put instance variables in here, so if you can add instance variables to an interface, and if you do that, they're what's called final. So final means that the value cannot be changed. It's just a value that exists and it doesn't change. It's like something like an interest rate, or trying to think, or some kind of user ID that never changes, or something like that. So just be aware of those. If you keep track of those 3 or 4 things, you usually can do pretty well with the interface questions that they throw you on the AP exam. They're not really all that difficult. So we have these here, and it's just saying which of the following are reasons why the program doesn't compile. So we have a program that's not going to run, and we have to figure out why. Now, there's a bunch of reasons why this program why the program wouldn't run, or basically all of these things are true about the program, right? But the one thing that causes it not to compile is the fact that circus performer is abstract, right? Does it say abstract here? No, but you have to know that circus performer is abstract, and you can't instantiate something from an interface, right? So that's basically all you need to know for this one. So like I said, those 3 or 4 things, that'll get you through at least half of the questions that you're going to get on interfaces, is just knowing those things about interfaces. I'm not going to give you an unfair question like this on the exam because, like I said, you're going to run into something like this, and a lot of these questions are going to be tricky this way on the AP exam. So I'm going to throw you the really tough ones on the study guides, but when we go to take the actual quizzes, you're not really going to, I'm not going to really, I just want to make sure that you know how those things work. I don't care to trick you or anything like that. But again, just be prepared for that, right? You're going to see things. Well, if you read the actual question carefully, that's 90% of the battle, right? I just need to know the answer to this. I don't need to know that all 3 of these things are true. Okay. Moving on, question 2, we have an interface in class, and it's just saying what's the output, right? So so we say we're creating we have circus performer still. It's I think this is the same as above, the circus performer interface, and then we have an acrobat class that implements circus performer. Let's make sure if you look at all your question options, there's 2 compile errors here. So we want to, those are the easiest to eliminate out of our list of things that we need to do, right? Most of these questions, you're going to need to double check yourself. So especially on my quizzes, and definitely on the AP exam, you're going to want to start eliminating stuff so that you can be sure your answer is right. And in a lot of cases with these, it'll also help you to come to the answer quicker. So you want to eliminate the possibility of either one of these 2 compile error messages, right? So did we implement a method that was not declared in the interface, right? Does that actually cause an error? That's an easy one. We can eliminate that right away, right? We can add endless amounts of, we can implement an interface in a class. We can add endless amounts of other methods and that'll be just fine. The point of the interface is just, that's your way to communicate with that interface. Is you have to make sure you have all this stuff, but if you have extra stuff, it's not going to cause a compile error. So we can eliminate D right away. And then we check E due to not implementing a method that was, so that's a no-no, right? If you implement an interface, right, you have to override all of these methods. So if I'm implementing Circus Performer, I need to make sure that I have these appropriate methods in there. So then I go and I look, okay, here's all the things. Is anything missing? Well, I have act, right? I have entrance, I have performance. What am I missing? Exit. So E is true, right? We're all done. We didn't even have to really look at the program and how it works. You guys have questions on that one? Okay, the first couple of these are pretty easy. Let's take a look at question 3. And again, 90% of your battle here is going to be to read the question completely and know exactly what you're looking for and reading every possible answer and try to eliminate things. All right. So we need to know what's going to be printed. So if you look, we have a declaration here, and we're going to say what's going to be printed. And then we have, again, some compile errors, right? Over and over again, I'm going to say this. Please, on the quizzes, if you're taking the AP exam, on the AP exam, eliminate your compile errors first. That's the biggest hint that I can give you, okay? So compile error 1. Let's go, since we already know the answer, let's go over a compile error message due to, again, it's the same thing, right? So I'm throwing these easy ones at you. This one was improperly using an attribute, right, in the interface. So let's see, private string name and private string name equals. Okay, so what do we do in here? What do we know about the strings or this? What do we know when I declare an instance variable in an interface? What do I know about it? What are the things that I know about any instance variable that's inside of an interface? Anyone? Yes. It's public by default, right? So that we're already messed up there. It's also final, and we tried to change the value there. Not a good idea, right? So we violated both of those two things. So that's why D. And again, I'm going to say this over and over again. Compile errors first when you do these. It's going to eliminate at least half of the questions. Any other questions on that one? Okay. Make sure if you get a chance to go over this again later. If you develop some questions, please talk to me. So let's see. Consider what is printed. Okay, so same kind of thing. We're creating an object based on the class that implements the interface, right? So we're going to find out what gets printed. Checking compile errors first. Improperly using an attribute. Did we do that? Nope, we declared it and gave it a value, and it's good. Let's see. And then so we didn't have that compile error. And then we know that's bogus, right? So just remember that you can add more. It's going to be really important to understand that you can add more methods even though they're not declared in the interface. So let's go through this. We're going to create a new Acrobat object called Ivan. We're going to give it the name Ivan, right? The name is going to be, the prename is the Great, and we're going to add Ivan to it. So it's going to, the name is the Great Ivan. We're going to run these methods, I believe, because we're doing act, right? So act runs all the rest of the methods. So here, so it's going to print out all this stuff. So the first thing we're going to return is the Great Ivan, right? So we look, which one has, see what I'm saying by eliminating things? We just didn't have to do a lot of work because we just started eliminating things first. So I know that this is going to, that we're going to return the name, right? So if I look, I know that the name is the Great Ivan. Do all of these have the Great Ivan? Only one of them has the Great Ivan, right? There we go. We're done. Answer C. So a lot of these are going to look super scary, especially on the AP exam. They're not that hard. You just have to know how to eliminate the wrong answers. Questions on that one? Please speak up if you got questions, guys. All right. Dance. Let's see. So we're looking at this interface, and we want to know which of the following correctly implements the interface. What's going to make it not implemented correctly, or what's going to cause a compile error, right? So this is basically telling you outright, find the compile errors. And there's only, even though this looks like a giant program to go through, it's really simple. You're looking at 3 implementations and you're seeing which one's right. Okay, so our choices are any of these, right? So let's double check them all. So Waltz implements, we have string music. All we need are these 2 methods in order for it to run properly, right? When we go here, we have play music and dance basic, play music, dance basic, play music, dance basic, and make routine. Do we have a compile error here? It doesn't look like it. We didn't improperly use any instance variables. We didn't leave out anything that's in the interface in any of these. And we didn't do anything else that would cause a compile error between those. So the answer is E, all 3. Simple so far, right? Questions? All right. Okay, dance class. Again, same thing. So we have an abstract class and it has abstract methods. This is not necessarily interface related, but it's abstraction, right? We have these abstract methods that if I extend dance in any way, right, 100% I have to implement these somewhere in there, right? So that would probably be the first one. Which one correctly declares, right? Meaning which one is not going to cause a compile error, right? So if I look through these, I'm looking for number 1, the easiest way to eliminate answers is to make sure that these are not left out, right? Play music, dance basic, play music, dance basic, play music, dance basic. Let's double check. Are they returning the right things? They're all void. I think these are all void. So we're good so far. What else? What else do we need? String M. So we got the call to super. What happened here? Okay, I said we didn't cover this a lot in the labs, so I set this one up for you just so you would see. this is kind of a goofy exercise to set up somewhere in the lab, so I didn't do it, but I wanted to make sure I covered it on quizzes and study guides, just because you're gonna see it if you if you actually write code after this, you're gonna see it as an error somewhere. Somebody's gonna screw this up, or on the AP exam itself, you're gonna see this again. One of those two things. So if I look at the dance class, right? I have a constructor with parameters. Do I have a default constructor? Remember, we've always, and I mean, this is a thing, we always do this, right? Every lab, I tell you, we got to have a default constructor. This is why, because eventually somebody else is going to screw it up and it's going to cause an error. So this has a default constructor. These both extend, right? But this one doesn't have a parameter, right? This one has the correct parameter. This one has no constructor, right? So if I don't have a default constructor here, right? But all I have is the constructor with parameters. I have to have a constructor with parameters in order to correctly extend or be a sub. If I'm going to write a correct subclass of a superclass, I have to make sure that I have a constructor with parameters if that's all that's in the superclass. Okay. If it asks for data and it doesn't give me an option to not enter data, I have to make sure I pass that data to it. So the only one here, and I'm going to double check. Yeah, subclass 1 is the only one that's actually correct because it took the right parameter and passed the data. Cool. All right. You're going to see these if you're taking the AP exam. This happens a lot where they give you this big giant thing of classes. Sometimes there'll even be more classes than this, and they'll even be a little bit longer. Some of these are several pages long. And then you'll have a series of questions that's based on everything that's right here. Okay. So I actually set up these classes for you just so we can see how everything works. Let's see. So let's double check these. So question 7, what is true about the code basically? Okay. You guys know I'm not going to give you a question like this on the exam, right? It's just designed to make you think so that you know what you need to know in order to answer the more basic questions that I'm going to give you. Basically all the questions that I'm going to give you on your actual quiz are going to be, okay, here's your class. Here's your interface. I'm going to give you these variables. This is what I'm doing. This is the driver. I'm going to instantiate something. What's the output, right? Simple. I'm not going to give you any of this like sort of, I don't know what the adjective I'm looking for is. I'm not going to give you any of these kind of like overly conceptual questions. Okay. So if I look, what is true about the design of the previously shown program code? Juggler, Equestrian, and Lion Tamer classes could implement the circus show directly without the use of the performer class. Let's see, is that the truth? So if I look, so it says implement circus show. So let's check Juggler. Has public void performance. So it doesn't, there's not really a lot to Juggler, right? So I look, the number one thing I need here, what's missing from Juggler that you would typically see in a class? Anyone? Somebody tell me if I'm looking at Juggler right now. Where is it? If I'm looking at this class right here, if I ask you to write a class, right, what would you include in this that you don't see here? you wouldn't necessarily need the variables. What I would say, what I'm looking for is a constructor, right? There's no constructor there. It's not a deal breaker under all circumstances, but what would make it a deal breaker is if Circus Show didn't have a default constructor. Okay. So let's see, public point entrance. So it looks like, if you look at it, Circus Show just says that we need to contain all these things, right? So Circus, I mean, we don't have to worry about constructors actually, because we're implementing an interface. So I got my question a little screwy. So what's true? Juggler, could it implement Circus Show directly without the use of abstract performer class? So all we need to do is check and make sure that they have all these things, right? So Juggler, is that true? Because if we just look at Juggler right here, it doesn't contain all the stuff we need, right? So basically, it relies heavily on inheriting that from Performer. So number one is out. Performer class is used for greater program writing efficiency. Hopefully, right? That's kind of the point of superclasses. So Performer has all the methods that we need. And then when we declare these, it allows us to not overwrite. We don't have to rewrite any of that stuff, right? So yeah, it's creating greater program efficiency, right? Performer abstract class is necessary for using polymorphic methods. So basically, polymorphism is anything that takes many different forms, right? So for instance, the method performance, right? It is contained in Circus Show and gets inherited by the rest of these, right? So there is a performance method in Juggler. So there's if I have a juggler named George, I can have George dot performance, right? I can have an equestrian performance, right? So I can have an equestrian named Martha. I can have Martha dot performance. That's the same method. It's all the same stuff, just many different forms of it, right? So those two are correct. So it's 1 and 2 only. Wait. No. Should be 2 and 3 only. That's wrong. I think that answer actually should be E, because you couldn't implement Circus Show. I mean, you could, but it's not done here. I'll have to take a second look at that question because I don't think that's the right answer. But basically, that's what you're looking for, right? Could I implement, if I just had this, if I just had Juggler, could that directly implement Circus Show? Obviously not, right? It doesn't contain all the stuff. So I think I meant to put I think I meant to do E there. That was weird. It's strange that I didn't get a question about that. You guys got to look carefully at the study guides, okay? Let's see. So question 8. Now we're declaring objects. This is cool. Basically, I'm creating juggler Sue equals new juggler. What do we need to know here? I mean, if we look at all these, right? What stands out to you the most? What do these all have in common? Maybe I'll be more specific. What did they all not? What do these all not have? When you're creating a new object, what do you usually want to give it? Yeah, you definitely want to give it parameters, right? You want to pass data to it. These are all not passing data. So what do we need to check? We need to check if there's a default constructor for everything that allows us to not pass data, right? Well, we have our superclass, and it does not appear to contain a default constructor, right? I'm trying to former class entrance. So it doesn't have. That's weird. I think trying to think if something got deleted. These are very confusing. You know what I think I'm gonna do? I'm gonna cut this short, but I think what you would see with these questions, these are I don't know if they're improperly copied or not, but what you should see here is that these have default constructors. Okay, you wouldn't need them here. You wouldn't need them in the subclasses, but you definitely need a default constructor in that superclass. Can't really have a class without a constructor, especially if you're going to start instantiating objects. So basically what this was originally designed to check is, okay, do I need what you would look here, you would see these, none of these have parameters. So you would actually need to look at the superclass and say, okay, if in the superclass, do I have a default constructor? Because if you looked at the superclass here and there was no default constructor and it's telling you needed a parameter, you'd be done already, right? That question would take you 2 seconds to answer. So that's kind of what that was, right? All you had to do there, if I was smart and put a default constructor there, all you would have to do was check that, and you would easily get past number one, or you would easily get past number one because it's not just one only, right? You could basically eliminate these three, okay? But the answer is clearly these are all right because you can do all those things. Let's see, performer is new juggler. Okay, the other thing that you want to check here too is that performers can be jugglers, right? The only thing you can't do is I can't say juggler is performer. That's what's called upcasting. So we're doing casting here, right? Which we've done before. We're taking the superclass object and making it a subclass object. What you can't do is you can't declare an object of type subclass and then make it a superclass object. That's not something that we're going to cover in detail in this part of the study guide. I'm gonna give you some more detailed questions about that on the next one, and I still have to fix this one, so that'll be forthcoming. But what you really want to check here is, do I have all the necessary parameters and everything, and can I do that? There's a little bit of subclass, superclass relationship stuff here, but all this stuff, that's the interface, superclass. These are all the same. So there's no discussion of upclassing or upcasting versus downcasting. Again, I'll cover that in the second part of the study guide. Don't worry about that. I'm going to go ahead and skip the rest of these for now. Let's see if do I have any more. I'm going to just skip those because that's improperly written. This. Okay, so partial implementation. So we have an interface and a partial implementation of the distance class. Let's see. Finds the greatest of three distances. So you kind of have to go through these and sort of see how they work. All you're doing is finding out what you do for your replacement code. Okay, so if I look, we know that this returns a double, and we know that that returns a string, so we don't really need to see those methods. So this one, finds which, so we have the greater distance object and saying which object is greater, A or B. So let's see, if which object, so this finds the greatest between two objects. This finds the greatest of 3 by running this. All right, I'm just getting my bearings around this one. Not the greatest. Okay, and then this one tested. So basically this, you don't even really need to know how any of these work. You kind of just trust that they're going to work. And then you have to find the code that tests that, right? So if all you know is that this returns a comp dis object, right? And it compares each one to find which one's the greatest. So let's see. 1, 2, 1. Ugh, this is a big one. Can't believe I didn't. I thought I checked this one beforehand, but I got to go through it all myself, which is kind of good, actually. What's the usual with greater? This object or compare returns. Okay, so we need to know it has. So you might have to eliminate compile errors with this. We need to know that we have a compare that returns a double. Double, not this. Yeah. Distance. Great. This A, compass 1. So if that one's greater, return that one. And then this one runs great. All right. So this one, you didn't even need to check how it works. No. So this one we didn't even need to know how it works because we're creating an interface object, right? Can we do that? We can't because interfaces are abstract, right? Okay, so segments 2 and 3 both work because grade of 3, it's expecting 3 parameters. Each of the distance object is a distance uses. Program compare object. What's different magnet types? Okay, so let's just go through. I'm doing this, and it's asking for these two. What is greater, A or B? So it's asking for, I put in the correct parameters, and I'm going to compare them. So that one will work. And then this creates the greatest distance. So this one kind of will confuse you a little bit because this all works correctly. And if you go through all of it, you realize that you actually don't need to, because the things that it's returning are either implementations that are not shown, or the question itself tells you to kind of ignore it, or not worry about it, that just assume that it correctly implements it, right? So all we need to really check here is, am I giving it the right stuff, right? And basically it's asking for, you want to create a new distance object and give it the right parameters, right? String double, string double, string double, and then print out what the greatest distance of. So you need to know that this is the grade of 3 is the method that returns the greatest of the 3 comp dis objects, right? So that's all it's going to do. It's going to return the comp dis objects that's the greatest of whatever these 3 are, okay? If we print that out, then that is an appropriate implementation of that code, or that's an appropriate replacement for that code, right? This one will get a little bit tricky because what do I want to say? What was I going to say here? 1, 2 only. Number 3 is wrong because we created a comp dis. This is okay here because it's a new distance object. Using the interface and the declaration actually allows us to use those together and compare them. So we could actually put all these objects into like an array list or an array together. And that's kind of the point of an interface, is we allow them to talk to each other in that way or be grouped together. But as long as we declare it as a new distance object, right, that eliminates the error that we would get with what we would do here, is we declare it as a new comp dis object. And you know we can't do that because we can't do it. We can't declare an object of a type that's abstract, right? So is there an abstract type here? That's an abstract type, so we can't. So we eliminated 3. We know this works because it has all the right stuff, and we can create an object of an object class, right? So here all you needed to know here really was that comp dis itself, right, is an interface, but as long as we declare of type distance and give it the right parameters, it's going to work, right? And we don't need to know how any of the inner workings of it were. And you see how I wasted time right there going through that. A lot of your job, and again, something that's kind of unfair on a quiz like this, I'm not going to give you. If you're preparing for the AAP exam, make sure you know how to do this, right? We all have to get better at, okay, what are the salient factors in the decision that I'm going to make? What part of this decision is the important part? What do I need to know to make an effective decision? And try to eliminate wasting brain power on other stuff. And you just saw how crippling that was here. That whole exercise just took me about 10 minutes when it should have taken me 30 seconds, right? I already know. I don't need to know how to do this. All I need to know is that going to compile? Because my choices aren't between like different types of implementations for this. My choices are, what am I going to put here that's going to give me some sort of an output? If they control your output like that, then you don't really need to know how all of this stuff works. They're going to put in comments, okay, this is how this works and this is what it does. And this is what your output's going to be, right? So they might throw something at you with the print statement where it won't print properly, or that wasn't implemented properly. So you have to kind of double check outputs and things like that. But once you verify that, all you need to know is, did I create the object properly? Is this possible? Is this going to cause a compile error? And did I give it all the appropriate parameters? Okay. Questions on that? I can't imagine there wouldn't be. That was a big bag of worms. Okay, please please see me later if you have more questions on that. This is a long one to read. Programmer has a task of maintaining a database of customers. All the customers have the same personal information stored, name, address, phone number, etc. Amounts of each product purchased. Dollar amounts of products are calculated differently for retail and wholesale customers. Returning customers have information about most frequent product purchase. Programmer will write a Java program. This is the important part. Start turning on your brain here. All this stuff you can come back and read later, right? This is the meat and potatoes. Programmer's going to write a Java program to handle all of the customer information. Which of the following is the best design in terms of programmer efficiency and reusability? So you're not really getting, you're not really seeing the complete implementation of a lot of these. You're just seeing, okay, what general map is going to look the most efficient, right? And so if I look, I have interface customer, retail implements customer, returning implements retail, wholesale implements customer, return. So I have 4 separate things. I'm not sure that that is necessary. So then I have customer, retail, returning retail, wholesale, returning wholesale. I'm trying to see what the difference between these is. Returning, implements customer, extends customer. Okay. So customer is an interface. Here, customer is an abstract class. In between these two, I would definitely go for the abstract class. The reason being, the interface doesn't help you make things more efficient, and programmer efficiency was a key term in that question, right? So that's what you're looking for, the most efficient. An interface isn't necessarily designed to create efficiency. What an interface is designed to do is, in programming, is the same thing that it's designed to do in every other aspect of your life, right? If I have a Bluetooth interface, it lets my phone talk to my car, right? Or my car stereo. If I have a USB interface, it lets me plug like a keyboard or a mouse or a microphone or something into a computer. It allows those two things to talk to each other. Same thing with an interface. Interface allows 2 different classes to either talk to each other, feed each other information, or be grouped together, say in an array list or an array. Okay, so right off the bat, I know that I'm looking for an abstract class here because I'm looking for efficiency, right? Returning retail, wholesale. So I have 4 things here. Public class customer. I would eliminate that one just because the customer is not, you're going to be looking for more specific customers. There's no, there's not going to be any generalized customer that you're going to have that doesn't have these attributes, right? Any customer that you're going to have is going to fit into one of these 4 categories. So you're going to want this to be abstract because you're not going to just go, oh, this guy is customer, right? Let's see, public apps. So we have the abstract, retail, returning wholesale. So here, these all extend customer, right? What you probably want to do is have retail extend, or returning retail extend retail, and returning wholesale extend wholesale. The reason why is probably if you've got a wholesale customer, right, it's going to share a bunch of things in common with your returning wholesale. Your returning wholesale, right, or your returning retail is going to contain all the same things as a regular retail, it's probably just going to have some additional information rather than be completely different, right? So these are all completely different, whereas in B, we're generating efficiency by taking all the things from retail and including it in returning retail, taking all the things from wholesale, passing it down. Everything's getting inherited. So we're creating the efficiency by not having to type all that code over again. Both of those extend customer. So we created an interface called customer info here. Customer implements info. These are all pretty good ways this is a pretty good way to do it. I don't know for sure that it's the most efficient just because I'm adding an extra interface, right? An interface, again, it doesn't necessarily, it doesn't create efficiency on its own. It, again, just allows different things to talk to each other. I don't see, since this is a self-contained, like sort of either point of sale or customer management system, I don't really see a reason for an interface between different types of customer objects. So I don't really think that that's a necessary thing. It may add functionality to other parts of the program, but it wouldn't necessarily create efficiency in how that works. So for our purposes, right, which is to create efficiency, according to the question, having that extra code in there isn't beneficial. Are we, is that relatively clear? Do we have questions on that? Okay. Certain interface provided by has just a single method. Okay, so returns an int, takes these parameters, right? So as long as it has that in whatever the subclass is, we know we're good. Programmer adds functionality to this interface by adding another abstract method to it, method 2. So we added another one, but it doesn't return anything. It returns void, takes the same parameters though. As a result of this action, which of the following is true? Method object, object 1, object 2, until object 1 and object 2 are not compatible. That wouldn't make a ton of sense. All classes that implement the original sum will need to be rewritten because they no longer. So if you already have classes written, right, and you add this later on, then all the subclasses you just wrote have to be rewritten to override the new method, right? A class that implements the original sum name interface will only need to modify its declaration as follows. And that doesn't make any sense, right? So that should be an easy elimination. Subname will need to be changed to an abstract class and provide implementation for method 2. So that doesn't make any sense either, because assuming that the rest of the program's already written, right? It's designed already to work with the interface. So all you need to do is add the appropriate extra method. So that doesn't make any sense either. Any new class that implements the upgraded version of some name will not compile. Again, that doesn't make sense either, right? It will absolutely compile because it's implementing the upgraded version we've upgraded. So a lot of these are conceptual, okay, which is why I'm giving you guys 2. So just I'm gonna fix these, and we'll go over them next class, and we'll also go over the new study guide. But try to understand most of this stuff conceptually, and I'll give you an updated version of this today that actually works correctly. I think we got 3 or 4 questions in here that aren't like what I would like them to be. So be on the lookout for that. And again, we're going to have more discussions next class. But try to get your brain around this stuff conceptually. And then, like I said, when I give you the new study guide, what I'll have is specific numbers and strings that we're going to be returning. Hey, does this work right? Here's the specific. Here's actual implementation of something. Does that work or doesn't it work, or which answer is true? Okay. So now we did nerdy stuff, and next time we'll do stuff that actually